A VLAN, guys, or virtual local area network, that is a network configuration that allows you to segment a physical network into multiple logical networks. So this segmentation is done to improve network management, enhance security, and optimize the performance. So actually, guys, it was very much hard for me to understand why we are using VLAN on the first day of my networking days. But after, day by day, it was easier to understand it. So generally, we are making virtual local area networks on the same switch and making them to communicate. So the main reason that we are using VLANs is separating the broadcast traffic. So as you know, on a local area network, broadcast traffic is not forwarded over a router. So routers are a boundary for broadcast traffic. But if you use VLAN, you don't need a router to eliminate the broadcast traffic. So you can use VLANs on a same switch, and the broadcast traffic will not be forwarded between that VLANs. So each VLAN has on its broadcast traffic. VLANs are not used on dummy switches, hubs, that kind of devices. So they can be used in managed switches. So please keep in mind that different VLANs cannot communicate each other without a layer 3 device such as a router or firewall. So what I mean here, let's talk about the VLAN communication now. So I have Fast Ethernet 01, Fast Ethernet 02, 03 and 04 ports of this switch. 01 belonging to VLAN 1, 3, 4 belonging to VLAN 2. Okay, so here the PCs in the same VLAN can communicate to each other. Okay, so this PC1 can communicate with PC2. Also, PC3 can communicate with PC4 because they are also in the same VLAN. But PC1 cannot communicate with PC3 and PC4. Okay, because they are in a different VLAN. In reality, in real life, we can have them communicated if I have a layer 3 device such as a router connected to here, and there are a few methods for that. I will show you in a short while. I mean in the other lessons, of course, not this one. But if there is no layer 3 device, there is no connectivity between other VLANs. Okay, so what is the benefit of using VLAN? First of all, VLANs allow you to create separate broadcast domains within a single physical network infrastructure. So it provides logical segmentation, guys. Devices within the same VLAN can communicate with each other, as I told you, and devices in different VLANs cannot communicate each other. Also, by isolating the traffic within VLANs, you can enhance the security. For example, sensitive data or systems can be placed on a dedicated VLAN, restricting access to authorized users only. VLANs also help reduce the broadcast traffic by limiting the scope of broadcast packets to only devices within the VLAN rather than across the entire network, and VLANs make it easier to manage the network changes, guys. So for example, you can move devices between VLANs without having to physically reconfigure network cabling or hardware. So VLANs are typically configured on network switches by using VLAN IDs, and devices are assigned to that VLANs based on these IDs. Okay, so let's continue with the types of the VLANs. There are basically six types of the VLANs. They are default, data, voice, management, native, and reserved VLAN. Default VLAN, guys, this is basically where all ports belongs to by default. So this is technically VLAN 1 for Cisco switches, and it cannot be deleted from the switch. Okay, so the second one is data VLAN. That is the normal VLAN where the traffic is carried and where the client data goes through the local area network. Okay, the third type of VLAN is voice VLAN that is configured to carry voice traffic. We have management VLAN. This is used on a local area network for management purposes. We have native VLAN. The native VLAN is a .1Q only concept. Okay, so traffic belonging to the native VLAN is not tagged by. Okay, so please note that by default VLAN 1 is the native VLAN on all Cisco switches. So you can designate any VLAN as your native on your switch, and again note that it needs to match on both ends of the trunk connection. We will come about this in a very short while. And we have the reserved VLANs. So there are some VLANs that are reserved internally on your switch in order to use them on other environments such as FTDI, token ring, etc. So those VLANs are the VLANs between 1002 and 1005. Here on the screen you are seeing a show VLAN output of a switch. You could see that we have VLAN 1, that is the default VLAN, and by default all ports are belonging to this VLAN unless you assign them to other VLANs. Okay, we have VLAN 10 that is defined as a data VLAN. Okay, so by the way guys, the data VLAN can be an IP camera VLAN, printer VLAN as well. This, for example, there could be some other definition like VLAN 20 named printer, and this would be also a data VLAN. Okay, and we also have the voice VLAN, which has VLAN ID 30 for this case, and it is assigned to this interface. We have management VLAN. This is with VLAN 40, VLAN ID 40 for this case, and those are the reserved VLANs that I spoke in this slide. How I am doing the voice VLAN? So it is always recommended to separate data and voice traffic, and most of the times we are using a separate VLAN to carry the voice traffic, guys. Usually IP phones sit next to a computer on the same desk, so they require the same cables as computers and also use Ethernet. This will work, but it has some disadvantages. So you need to install a new cable from the switch port to the IP phone. You will lose a switch port for the only IP phone usage. Okay, to solve this, most IP phones have a 3-port switch inside of the IP phone. One port connects to the switch, one port connects to the computer, and the one internal port that is not visible most of the time port connects to the phone. So this allows us to connect the IP phone and computer like you see in the screen. Okay, so for example, there is one cable connected to this fast Ethernet 016 port of this switch. Okay, this cable is coming to IP phone. So IP phone has one port that this cable is plugged in. Also, IP phone has another port. Okay, this port is used to connect to this PC. So what happens, what is the advantage in here? You just use one port from your switch to the IP phone instead of using two different ports, one for IP phone, another for PC. Okay, so you just save from the switch port usage. So what I'm defining also in here, I'm going ahead to the Fast Ethernet 016 port, interface Fast Ethernet 016. Then I am typing switch port access VLAN 10, that is to define my data VLAN, that is the usage of the PC. And also I am typing switch port voice VLAN 30, which means I have a voice VLAN of VLAN 30, and that is for the usage of the IP phone. So let's continue with trunking. We have two modes of switch ports, and they are access and trunk. Okay, an access port can carry a single VLAN. However, a trunk port carries multiple VLAN information between different switch ports. Okay, so each frame sets the VLAN information, and that is known as tagging tool. So for example, let's have a look to my screen again. As I told you, access VLAN can carry just one VLAN. On the other hand, trunk can carry multiple VLANs. Okay, so here I have my Gigabit Ethernet 01 port, Gigabit Ethernet 02 port, and those are assigned to VLAN 100, and the other one is assigned to VLAN 200. Same thing applies to the switch too. Okay, so in here, Gigabit Ethernet 01 port is an access port, guys, which means it is only responsible to carry the traffic from VLAN 100 only. Okay, Gigabit Ethernet 02 port is also an access port. It is connected with only one VLAN, and that is VLAN 200. On the other hand, there is a trunk port configured in here. Trunk port means it can carry multiple VLANs. This trunk port in here should carry VLAN 100 as well as VLAN 200. So if PC1 wants to communicate with PC3, as well as if PC2 wants to communicate with PC4, they should be able to communicate by the help of this trunk configuration. Okay, trunk means multiple VLANs, access means just one VLAN. Trunk ports are used to carry traffic that belongs to multiple VLANs between devices over the same link, as I told you, and a device can determine which VLAN the traffic belongs to by its VLAN ID. So VLAN ID is a tag that is encapsulated with the data. ISL and .1Q are two types of encapsulation that are used to carry data from multiple VLANs over trunk links. ISL is a Cisco proprietary protocol for the interconnection of multiple switches and maintenance of VLAN information as traffic goes between switches. On the other hand, .1Q is the IEEE standard for tagging frames on a trunk.